Hello everyone, welcome to EnviroPioneers. In this video, we are going to discuss some of the numericals and the MCQs based on the relative humidity, lapse rate, and atmospheric stability. Simple numericals or the concept-based questions on these topics are generally asked in the competitive exams like the MSc entrance exam or the UGC NET environmental science exam. These topics we have already covered in their respective videos. If you are new to our channel, you can find the link to these videos in the description box, or you can visit Air and Air Pollution playlist in our YouTube channel EnviroPioneers. Most of the numericals on the relative humidity are based on this formula and this concept. Let us have a quick revision. Relative humidity is the ratio of the air's actual water vapor content compared with the amount of water vapor required for the saturation at that temperature. So we can calculate the relative humidity as mixing ratio divided by saturation mixing ratio into 100, or it can be written as vapor pressure divided by saturated vapor pressure into 100. So relative humidity is always given in the percentage. Another important concept in the humidity is the dew point. So the dew point is defined as the temperature at which air reaches the saturation and is directly related to the actual moisture content of a parcel of the air. So let us see the numericals based on these concepts. So the first question that we have here is saturation vapor pressure at a given temperature is 900 millibar, while the vapor pressure at the dew point temperature is 600 millibar, and the relative humidity is asked. So as we saw that the vapor pressure at the dew point temperature, it represent the actual water vapor content in the atmosphere. So as per this question, the actual vapor pressure, that is 600 millibar, and the saturation vapor pressure is 900 millibar. So as we know, the relative humidity can be calculated by using this formula, actual vapor pressure divided by saturation vapor pressure into 100. We will be simply dividing the 600 by 900 and then we will multiply by 100. So when we solve this, we'll be having 66.666%. So if we see the option in these four, so this is the correct answer. So for this question, 66.7% is the correct answer. Next question is, a sample of air has a relative humidity of 60%. Given that the saturated vapor pressure is 2260 Pascal, calculate the vapor pressure of the air at 20 degrees Celsius, and these are the options in which we have to choose the correct answer. So here we have the value of the relative humidity and we have to calculate the vapor pressure of the air. So the relative humidity is the 60% and the saturation vapor pressure is given 2260 Pascal. So we have this formula, relative humidity is equal to vapor pressure divided by saturation vapor pressure into 100. So we will put these value at the respective places. So relative humidity is 60 and saturation vapor pressure is 2260. So when we calculate this further, vapor pressure is equal to 60 into 2260 divided by 100. So for simplifying, I have mentioned zero point 0.6 into 2260. Further calculating it will give us the value 1356. So if we see here the options, fourth one is the correct answer, that is 1356 Pascal. Next question is, at 30 degrees Celsius, the saturation vapor pressure is 42.4 hectopascal, and if the actual vapor pressure is 21.2 hectopascal, calculate the relative humidity. So before moving further in this video, I want you to take the pause and try to solve this question. So in this question also, we will use the same formula, actual vapor pressure divided by saturated vapor pressure into 100. So actual vapor pressure is 21.2 hectopascal, saturated vapor pressure is 42.4 hectopascal. So when we calculate this 21.2 divided by 42.4 into 100, so we will be getting the answer 50%. So the answer to this question is 50%. In the next question, it is mentioned that air temperature is 25 degrees Celsius and the dew point is 15 degrees Celsius. And here we have the saturation vapor pressure at 25 degrees Celsius that is 31.7 hectopascal, and saturation vapor pressure at 15 degrees Celsius, that is 17 hectopascal, and we have to calculate the relative humidity. अब यहाँ पे अगर आप नोटिस करो, डायरेक्टली एक्चुअल वेपर प्रेशर या सैचुरेटेड वेपर प्रेशर नहीं मेंशन किया है, but here they have mentioned the air temperature and the dew point temperature. So we know that the dew point temperature, it is related to the actual moisture content in the atmosphere. So the vapor pressure at the dew point will be the actual vapor pressure, and the vapor pressure at the air temperature will be the saturated vapor pressure. So now if we have to calculate this quotient, we know this formula of relative humidity. So we will simply put the value of actual vapor pressure and the saturated vapor pressure in this formula. So here we have the 17, that is the actual vapor pressure, and this is the saturated vapor pressure 31.7. So यहाँ पे हमारा हो गया 17 divided by 31.7 into 100. So when we calculate this, we will be getting 53.6%. Now coming to the questions related to the lapse rate, as we discussed in the video of the lapse rate that it is of two types, environmental lapse rate and adiabatic lapse rate. Environmental lapse rate is the rate of change in the actual temperature of the atmosphere, and it is measured using the radiosondes, and its average value is 6.5 degrees Celsius per 1000 meter. And the adiabatic lapse rate is the rate of change in the temperature of an air parcel as it moves vertically in the atmosphere, and the value of the dry adiabatic lapse rate can be 10 degrees Celsius per 1000 meter for unsaturated air parcel, and it is referred as the dry adiabatic lapse rate, and its value can be in between 5 degrees Celsius to 9 degrees Celsius per 1000 meter for the saturated air parcel, and it is referred as the wet or the moist adiabatic lapse rate. So let us see the question based on the lapse rate. Here we have the first question. In the tropical region, an aircraft is flying at an altitude of 10 km. At that altitude, the temperature is minus 40 degrees Celsius. What is the ambient temperature on the ground? So in this question, the temperature at the altitude of 10 km is given, and we have to calculate the ambient temperature on the ground. So we know that the environmental lapse rate is 6.5 degree Celsius per kilometer. So किसी भी question में अगर कोई value mention नहीं है environmental lapse rate की, we always take the default value or the average value of the environmental lapse rate, that is 6.5 degree Celsius per kilometer. Using this lapse rate, अगर हम 10 किलोमीटर के लिए rate of change calculate करें, it will be 6.5 into 10, that is 65 degree Celsius. So ground से 10 किलोमीटर की height पे जो temperature mentioned है, that is minus 40 degree Celsius. We know that in the troposphere, we have the decrease of the temperature with the altitude. So if we have to calculate the temperature on the surface, we have to simply add 65 degrees Celsius into this value, and we'll be getting 25 degrees Celsius on the ground. So the temperature of the atmosphere near the surface is about 25 degrees Celsius. So let us see the option. Here we have 24, 40, 30 and 20 degrees Celsius. So the most closest answer is the 24 degrees Celsius. So the correct answer is the first one, that is 24 degrees Celsius. In the next question, it is mentioned that if these symbols represent the dry adiabatic, saturated adiabatic lapse rate, and the environmental lapse rate respectively, the condition for the unstable atmosphere is. And here we have the options. So as we discussed in the video of the atmospheric stability, that for the unstable atmosphere, the environmental lapse rate, it is more than the dry adiabatic lapse rate. So if we see the options here, so the first option is the correct answer, where the environmental lapse rate is more than the dry adiabatic lapse rate. This is also the similar question, but mode of representing the lapse rate is different. So this is the saturated adiabatic lapse rate, this is environmental lapse rate, and this is dry adiabatic lapse rate. And the condition is mentioned that the environmental lapse rate is more than the saturated adiabatic lapse rate, but less than the dry adiabatic lapse rate, and the stability of the atmosphere is asked. So as we saw that if the environmental lapse rate is in between the moist adiabatic lapse rate and the dry adiabatic lapse rate, the atmosphere is conditionally unstable. So the correct answer to this question will be the B option, that is conditionally unstable. In the next question, it is mentioned that at a given urban location, the temperature at an elevation of 25 meter above ground is 15 degrees Celsius. If the inversion condition prevail and the environmental lapse rate is 1.25 degrees Celsius per 100 meter, what is the temperature at an elevation of 200 meter? So in this question, if we consider the brown line as the ground, at the height of 25 meter, the temperature is given 15 degrees Celsius. And as we move up in the atmosphere, there is inversion condition, means there is increase of temperature by 1.25 degrees Celsius per 100 meter. Now at the height of 200 meter, the temperature is asked. So first we will calculate the elevation difference, that is 200 minus 25. This is total 175 meter. Now the lapse rate is mentioned 1.25 degrees Celsius per 100 meter. So the temperature increase for 100 meter is 1.25. So we can calculate for 175. So simply 1.25 divided by 100 into 175. So we get 2.1875 degrees Celsius. So as we are having the increase of the temperature with the height, so we will add this into this value. So 15 plus 2.1875 will be getting 17.1875 degrees Celsius. So if we see in these options, so this one is the closest answer. So the correct answer is 17.25 degrees Celsius. Next question is, when the temperature of the atmosphere falls at a rate greater than the dry adiabatic lapse rate, the atmosphere is stable, highly stable, unstable, and conditionally unstable. So as we know that if the environmental lapse rate is more than the dry adiabatic lapse rate, the atmosphere is unstable. So the option C is the correct answer. Next question is, if the tropospheric lapse rate is 6.5 degrees Celsius per kilometer and if T denotes the temperature and Z denotes the altitude, then how we represent the lapse rate? So dt by dz 6.5 degrees Celsius per kilometer, dt by dz minus 6.5 degrees Celsius per kilometer. Here we have dz by dt 6.5 degrees Celsius per kilometer or dz by dt minus 6.5 degrees Celsius per kilometer. As we discussed in the video of the lapse rate, that lapse rate is the rate at which temperature decreases with height in the atmosphere, and its formula is this minus dt by dz. तो यहाँ पे जो हमारा ये ऑप्शंस है इसमें सी और डी तो ऐसे ही गलत हो गया बिकॉज डी जेड बाई डी टी है और इन दोनों ऑप्शन में दिस इज करेक्टली रिप्रेजेंटिंग द लैप्स रेट. सो ऑप्शन बी इज द करेक्ट आंसर. Next question is based on the adiabatic lapse rate. The question is, a parcel of unsaturated air at 28 degrees Celsius rises to 2 km. What will be its temperature? And the dry adiabatic lapse rate is mentioned 10 degrees Celsius per kilometer. So if you remember this image from the adiabatic lapse rate, as the parcel moves up, it expands and it cools at the rate of dry adiabatic lapse rate and the value is 10 degrees Celsius per kilometer. So the temperature near the surface is 28 degrees Celsius. So for first 1000 meter 28 minus 10 it will be 18 degrees Celsius and for further 1000 meter 18 minus 10 8 degrees Celsius. So the correct answer to this question will be 8 degrees Celsius. These were the questions taken from the previous year papers of the UGC NET Environmental Science exam. We will meet soon in the next video related to the cloud formation. Thank you and best wishes.